All right, now I'm about to show you guys how to apply Newton's second law to Attwood's machine. So that's when we have two masses that are hanging with a pulley. So we have a 3 kilogram mass and we have a 5 kilogram mass. So just like before, the first thing that we want to do is to draw a free body diagram for the motion for the first object. And we're going to say that's the 3 kilogram object. And we're looking for acceleration and tension. So for the first object, we have the force of gravity, and then we have the tension force. So the sum of our forces in the y direction for this, since it's moving in the y direction, would be tension minus the force of gravity is equal to m1ax, where tension is equal to m1ax plus fg, the force of gravity. And for the second object, it would be tension and then the force of gravity for the second object. And the sum of the forces in the y direction would be T minus Fg2 is equal to M2A y. Oops, sorry, there should have been a y up here. Now, notice that this box is moving up, so M1AY is going to be positive. But for this box, it's moving down. So if this box is moving down, then it's going to be negative M2AY. And then solving for tension here, I get tension is equal to negative M2AY plus the force of gravity for that object. So now we have T equals this and T equals this. And remember, the tension here is the same. So I can equate both of those. So what that will be is M1 AX, or oops, sorry, AY is equal to, plus FG, can't forget that, is equal to negative M2 AY plus FG2. So I know my A's are the same, so I can just replace those with A, M1A plus the force of gravity for the first object is equal to negative M2A plus the force of gravity for the second object. Now if I get all my like terms on one side, so I move this over here, and then I can move this over here, I get everything with A on one side of the equation. Then I'll factor out an A. Final step, I can divide by the sum of the masses. So the acceleration is going to be the second mass minus the first mass divided by, the second force of gravity minus the first force of gravity divided by the sum of the masses. So it's going to give me the second force of gravity will be 5 times 9.8 minus 3 times 9.8 divided by the sum of the masses, which is 5 plus 3. Or I can, So putting all that into my calculator, what I get is 2.45 meters per second squared. And then last step, if I want to find the tension, remember I can use this equation or this equation because the tension is the same. So it can be, I can use this equation, So my mass for the first obstacle was 3 times 2.45 plus the force of gravity for that, which is 3 times 9.8. What I'm gonna get is 36.75. Likewise, so first I'll put 36.75 newtons is my answer. But likewise, I can use the second equation. If I use the second equation, and I plug in my numbers, this is going to be 5 times 9.8. What my final answer is going to be is 36.75 newtons, which is the same. So I did this problem correctly. So that's how you solve Attwood's machine. So anytime you have masses hanging like this. I hope this video was helpful.